Welcome back. Today we're going to talk about trigonometric substitution. Let's start by deducing certain identities that we're going to use. Okay, first, one of the simplest identities in trigonometry that you probably have seen is sine squared theta plus cosine squared theta equal to 1, which is a Pythagorean identity. This is one of the identities. The other one is a consequence of this. If you divide every term by cosine squared, for example, you'll get sine squared theta divided by cosine squared theta plus cosine squared theta divided by cosine squared theta equals 1 divided by cosine squared theta. Therefore, what you have here is tangent squared plus 1 cosine squared divided by cosine squared, and 1 divided by cosine squared is simply secant squared theta. So we have an identity of tan squared plus 1 equals secant squared. Okay, we're going to use these identities. You can create similar identities for cotangent. Something like cotangent squared theta plus 1 would be cosecant squared theta. These are the consequences of simply the first identity, the Pythagorean identity. Okay, so let me mention this. If some of the integration uses square root of a squared minus x squared, if you have an integral that there is this square root involved somewhere, somehow you find that the simple substitution of a squared minus x squared, let's say if it was square root of maybe 4 minus x squared, and you notice that if I ask you to calculate this integral, a simple substitution of calling this u would not help out because there would be an x showing up in the derivative and we cannot calculate the integral simply. So what we can do is we can use this identity, the identity of sine squared plus cosine squared equal to 1, and let the x variable to be a sine theta. So this is our substitution. So we substitute x with a sine theta, where a is a constant. And in this case, the domain of a theta is restricted to negative pi half to pi half. And why we do this is because if you replace a sine theta for x, what you get is minus a squared sine squared theta. You replace x with that, and this is simply square root of a squared times 1 minus sine squared theta. And what we know is 1 minus sine squared equals to cosine squared by this Pythagorean identity. Therefore, this could be simply square root of a squared cosine squared theta, which is simply a cosine theta. Okay, so this is the good thing about picking this substitution, is that you can simplify this square root to a cosine theta, where a is a constant. So basically, you'll end up with cosine theta, and we can integrate that. Similarly, if you're dealing with a squared plus x squared, this is a plus. The difference here is minus here, a minus x squared and a squared plus x squared. Instead of picking x to be a sine, you can pick x to be a tangent. Just because in that case, what we get is a squared plus a squared tan squared theta. And that is square root of a squared 1 plus tan squared theta. Sorry about that, tan squared theta, which is a times secant squared, a squared times secant squared. This is the identity. So what we get at the end is a secant theta. Again, you can simplify this complicated square root by the choice of this substitution, and you'll end up with a secant theta. Then you can integrate and simplify. Similarly, if you're dealing with x squared minus a squared, here's the difference between these two. Here you have a squared minus x squared. If it was the other way, x squared minus a squared, you need to choose the substitution to be x to be a sine theta, a secant theta, because in that case we can replace secant squared theta minus 1 with tan squared. Again, this is a consequence of that. You can move the 1 to the other side, and you will get secant squared minus 1 equals tan squared. So what this square root will simplify to, let me write it. It will simplify to, if we factor, sorry, I wrote it in the wrong order. You're replacing x with a secant theta. So you'll get a secant squared theta minus a squared, which will simplify to a times secant squared minus 1, which would be a tangent theta. Again, this a is just a constant. You will see in the examples. So not always it's required to use this substitution. But if you see something like a minus x squared, you can think about the substitution of x equal to a sine theta. If you see square root of a plus x squared, you can use a tangent. And if it is square root of x squared minus a squared, use a secant theta. Not always they're going to work out. Sometimes a simple substitution will suffice, and you don't need to go back to using this trigonometric substitution. Hopefully I will show you in an example. So let's start with this example. Let's say you have integral of 9 minus x squared divided by x squared. What we knew before is that normally we would use this. If we say 9 minus x squared, we call it du. Then negative 2x dx would be du, and dx would be du divided by negative 2x. If you do this, what we get is the integral of square root of u. Actually, you can call this u divided by, or you can call it u squared if you want. Let's say call it u. Let's see where the problem is. You have x squared multiplied by, instead of dx, you get 2 du divided by negative 2x. You notice these guys do not cancel out. That's the issue that we're dealing with. You have a higher degree here, you would have x squared, and on the other side you have multiplied by negative 2x, which is not going to help out. So this substitution is not a good choice for substitution. So if we look at, let me erase these stuff, sorry. Okay. Here we go. So if we look at the square root that we have, is very similar to 9 minus x squared. It's similar to a squared minus x squared. When in this case, a is given to be 3. So what you have is 9 squared, which is basically the integral of square root of 3 squared minus x squared divided by x squared dx. In comparison with the first identity, with the first choice of substitution, I don't know why that. What we can pick as substitution is a different color for the substitution. We can pick the substitution to be x to be a sine theta. This is our substitution. So I'll replace x with a sine theta, but I already know what a is. A is given 3, so I can replace that with, say, is 3 sine theta. Therefore, now dx, I divide both sides, multiply both sides by dx. This is 1. Derivative of x is 1. Derivative of 3 sine theta would be 3 cosine theta, and multiply by d theta. Okay, so therefore dx, we already solved for dx. dx is given 3 cosine theta d theta. So if we rewrite this integral, what we get is square root of 9 minus, instead of x, replace 3 sine theta. What we get is 9 sine squared. We have to square it and divide by, again, x is given 3 sine theta. So I can replace x here and say, okay, this is 3 sine theta squared. And multiply by dx is given 3 cosine theta d theta. Okay, so here, what do we get? We end up with the integral. Square root of 9 minus 9 sine squared is simply, you can factor 9, and what you get is 9 times 1 minus sine squared theta. You can skip this step because I already mentioned it in the idea, but if you write it, you'll notice the structure always. This would be very similar. 9 sine squared theta. Okay, this is simply square root of 9 is 3. Square root of 1 minus sine squared, which is cosine squared, would be just cosine. So you would get integral of 3 cosine theta, multiply by another 3 cosine theta, divide by 9 sine squared theta, and d theta. Okay, what does that simplify to? This simplifies to the 3 and 9 will cancel out. What you have is cosine times cosine divided by sine squared. That is cotangent squared theta, d theta. Do we know the antiderivative of cotangent squared? And the answer should be yes. The antiderivative of cotangent squared is the antiderivative of cotangent squared, we don't know what it is, but we can use this identity. Here's the identity. Cotangent squared of theta is cosecant squared theta minus 1. Right, so I can replace cotangent squared with cosecant squared minus 1. So this integral would be integral of cosecant squared theta minus 1 d theta. So now I can integrate. What is the integral of cosecant? It's negative cotangent theta. What is the integral of negative 1? Minus theta. Plus some constancy. Here is the only issue. We need to go back and replace these with the original value of theta. So what we have is, here we chose x to be 3 sine theta. So what is theta? Because we need to replace theta back. Theta would be, divide both sides by x. So let me write it step by step. Sine theta would be x divided by 3. So what is theta? You take an inverse function. Theta would be sine inverse of x over 3. So what we have is negative cotangent of sine inverse of x over 3 minus sine inverse of x over 3 plus some constant. And you would see that we already learned how to simplify this from the other sections. When we talked about the inverse of trigonometry, you can always draw this triangle and say this is theta. Given sine theta to be x third, sine is opposite, divide by the hypotenuse. So this must be x, that must be 3. So you can calculate this length, which is 3 squared minus x squared, which is 9 minus x squared. So therefore, I can say what is the negative cotangent theta? Negative cotangent theta would be negative. Cotangent of this angle would be adjacent divide by opposite. So it would be square root of 9 minus x squared divided by x minus sine inverse of x over 3 plus some constant. And this is, yes, it's a bit complicated, but what you need to notice is that the choice of substitution was kind of important. If you pick the other substitution, it's not going to be easy to solve. Okay, so I chose this substitution precisely just because of the case that we're dealing with square root of 9 minus x squared. Chose this substitution. Okay, at the end, we had this cotangent squared. Since we didn't know the integral of cotangent squared, we could have used identity, replace it with cosecant squared minus 1. It's very common to do this, replacing cotangent squared or tangent squared with the similar trigonometry identity where we know the antiderivative. If it was tangent squared, I would have replaced it with secant squared minus 1. It all comes from this identity. Okay, let's look at the next example. You choose. Okay, so if you look at this example, you should be able to guess what would be the choice of substitution. In this case, we choose x to be a, which is 2, square root of 4, which is 2, secant square theta. So therefore, this integral could be written as 1 divided by 2 secant square theta multiplied by square root of 4 secant square theta minus 4. And instead of dx would be the derivative of 2 secant squared would be sorry, 2 secant. Why is there a square? 2 secant theta. Derivative of 2 secant would be 2 derivative of secant, secant tangent. So I can replace here, instead of dx, I can write 2 secant theta times tangent theta, d theta. This term, this is 2 secant square, secant theta, sorry, 2 tangent theta, 2 tangent theta. You can factor out the 4, secant squared minus 1 is tan squared, so the square root would be 2 tan theta. So the integral simplifies to, you have the 2 can cancel out, tangent can cancel out, and you can cancel out one of the secants with one of those secant. By the way, this was supposed to be 4, because there is a squared here, x squared. So what we end up with is 1 divided by 4 secant theta, d theta. It may not look easy to see at the moment, but if you change it back to sine and cosine, what is 1 divided by secant? 1 divided by secant, secant is 1 over cosine. So 1 divided by 1 over cosine is simply cosine. So this would be simply 1/4 times cosine theta, d theta. And you can integrate that. What is the integral of cosine theta? It's simply sine theta. So you will get 1/4 sine theta d theta. Sorry, there is no d theta, plus c. Okay. Same issue that we had the last time. We need to draw this triangle to figure out what is theta, because we have to replace this sine theta. Okay, so I'll draw the triangle. Here's the angle theta. What we know is x is given x over 2. X over 2 is given as secant theta. So secant, which was 1 divided by cosine, which is hypotenuse divided by the adjacent side. That means this is x, that is 2. This is supposed to be hypotenuse divided by the adjacent. So correspond to that, x must be hypotenuse, adjacent must be 2, and we can calculate this length, which is x squared minus 4. Okay, so therefore I can answer, what is the sine theta? 1/4. Sine theta, sine of this angle would be opposite divided by hypotenuse. The square root of x squared minus 4 divided by x plus some constant. And here we are at the integral. Okay, this one looked much easier than the one before, because every term cancelled out. You can check to see if this is the, again, to check you just need to take the derivative, but the derivative involves quotient rule and general power rule composed with the chain rule. So you need to be kind of careful to take the derivative. Okay, here's another example. Maybe shift this up a bit. Okay. The question is, find the integral of x divided by 1 minus x squared dx. Here. What would be the choice of substitution? I want to show you something about this question. If we pick x to be sine squared theta, sine theta, what you would get is dx would be cosine theta d theta. This integral would be, instead of the x, I can write sine theta. Instead of 1 minus x squared, that simplifies to square root of 1 minus sine squared theta, which is simply cosine squared. So this would be simply cosine theta. And dx would be cosine theta d theta. Right? Write it. 1 minus sine squared theta. And this would simplify to sine theta divided by cosine theta times cosine theta d theta. Okay, these two can cancel out. What do you get is the integral of sine theta d theta. What is that integral? It's simply negative cosine theta plus some constants. Right, so this would be the answer. If we draw the triangle, there's the angle theta. Sine theta is given as x over 1, so this must be x, that must be 1, so this is square root of 1 minus x squared. So I can answer this question and say negative cosine theta would be negative square root of 1 minus x squared divided by 1 plus c. Just simply just that. Don't need to divide by 1. Okay, so this is, if we pick the correct substitution, this is what we get. You notice that it doesn't really get super complicated if you pick this as the choice of substitution. And let's see if we try a different substitution. If we try, not sure if it works, but what if we pick one minus x squared dx? What if we pick what we learned earlier? So the same question. What if I pick 1 minus x squared to be du? Then what do I get? I get negative 2x dx equals du. Therefore, instead of dx, I can write du divided by negative 2x. So dx would be du divided by negative 2x. So this integral could be written as integral x divided by square root of u multiplied by du divided by negative 2x. These can cancel out. So what we end up with is integral 1 over square root of u, and multiply by negative 1/2, so I can write the negative 1/2 outside du. But we should be able to calculate this integral. This integral is simply negative 1 over 2. You can write this as u to the power negative 1/2 du, and add 1 to the exponent divided by the same exponent. So you can get u to the power positive 1/2 divided by 1/2. These two can cancel out, plus some constant. So what we end up with is negative u to the power 1/2, which is square root of u, plus some constants. What is u? U is chosen to be 1 minus x squared, plus some constant. So we found the integral. And if you compare these two, same answer. It turns out sometimes it's not necessary to go to the trigonometric substitution. The simple substitution will work, but the problem is that this idea not always works, but the trigonometric is more often that is going to give you the answer. Okay, so if you can calculate it through this integration format, you can find it through trigonometric as well, but the other way around is not possible. So sometimes maybe choosing this substitution would be easier than going back to the trigonometric substitution. Here's one more example. This is kind of a bit tricky. I picked this example for the reason. You notice that this denominator has square root of 4 minus x plus 1 squared. So it's not x squared anymore, it's x plus 1 squared. So what you can do is you can use a substitution first. Sorry, let me rewrite. Okay, so what you can do is first you can write this in terms of a new variable. Call it u or something. So we can write this and say, okay, I'm going to call x plus 1 equal to t. So then dx equals dt. So what do I get is the integral of x divided by square root of 4 minus t squared dt. There is an x left in the numerator and I cannot cancel it out. So what I can do is I can use the first equation to solve for x. What would be x from this equation? X would be t minus 1. So this would be integral of t minus 1 divided by square root of 4 minus t squared dt. Now here, there is a good thing about this integration is that now it has the format that we can choose our trigonometric substitution. By the way, you can break this and write it into two separate fractions and calculate each one separately, but let's try to do it in one. We can. So let's pick our substitution. We call t to be 2 sine theta. Then dt would be 2 cosine theta d theta. Okay, so let's replace. Instead of t, I can write 2 sine theta. I have minus 1 divided by square root of, we've already done this a million times, but I'm going to write it again. 4 minus 4 sine squared theta and multiply by 2 cosine theta d theta. Okay, so this integral would be integral of, this is simply 2 cosine theta. So these two can cancel out. So what we have is 2 sine theta minus 1. And we need to integrate that. The integral will be simply negative 2 cosine theta, because the integral of sine is negative cosine, and the integral of negative 1 is minus theta, plus some constants. Here is the important part. You go back and say, okay, what was the cosine theta on negative t? So first, draw the triangle. What we know about this is we call this theta. We know t divided by 2 equals sine theta. And sine theta is opposite divided by hypotenuse. So this is t, this is 2. This would be 2 squared minus t squared, so which is 4 minus t squared. Pythagorean identity. This is a right angle. So I can answer this question and say negative 2 cosine theta would be square root of 4 minus t squared divided by 2 minus theta. What is theta? Theta, we cannot figure it out through the triangle. We have to figure it out through this. Theta would be sine inverse of t over 2. So I can write theta as sine inverse of t over 2. Right? Plus some constancy. Okay. We're not done. Don't forget that we did the substitution originally. So we have to go back and replace that. By the way, these two can cancel out. So you get minus square root of 4 minus, instead of t, I have x plus 1 squared minus sine inverse of x plus 1 divided by 2 plus some constant. And this is the result of this integral. It is a bit more work than what we expect. So if you notice that it doesn't have the format that you expect, you can maybe do an intermediate step of doing a substitution first, then deal with the integral. Write it in the way that you can see that trigonometric substitution. In this case, the idea was to replace x plus 1 first with the new variable. Then after that, we use the trigonometric substitution.